87 to 99%. Just let that sink in for a second. That is the staggering prevalence of work-related musculoskeletal disorders reported among Malaysian office workers. We are not talking about rare isolated incidents here, or just a few minor aches and pains after a long day. No, we are looking at an urgent, widespread workplace epidemic.
Welcome, students, to this explainer. I am super excited to be your host today as we replace our physical class to really master subtopic 7.1. We're going to be exploring the human blueprint, ergonomics, workstation design, and the anatomy of repetitive strain injuries. This is exactly where physiological theory crashes into the physical reality of the modern workplace. And grasping this, well, it's absolutely vital for your future careers in occupational safety and health.
So, here is our agenda for today. First, the human blueprint. Second, anatomy of the RSI cycle. Third, Malaysian law and employer duties. Fourth, identifying and assessing risks. And finally, engineering the ergonomic solution. We're taking an ecosystem approach to all of this today. All right, let's jump right into part one, the human blueprint. This is the raw biological reality of the human body at work. Okay, let's dive into a foundational concept you absolutely need to know: anthropometry. Simply put, this is the scientific measurement of the human body, used to engineer compatible working environments. The crucial takeaway here is that true ergonomics is always about forcing the machine, the workstation, the physical tools, to fit the human. We never, ever force the human body to adapt to a poorly designed machine. I don't care how much you might end up looking like a pretzel hunched over your laptop, it's just wrong. So what does that perfect fit actually look like? Well, there are specific physiological targets we need to hit. First up, your vision. It should be aligned with the top of the monitor at or slightly below eye level, keeping a safe viewing distance of about 40 to 75 centimeters. Now think about the spine and pelvis. Proper lumbar support needs to be fully engaged to preserve that vital, natural S-curve of your spine. And for the upper and lower limbs, we are aiming for precise 90-degree joint angles at the elbows, hips, and knees, with your feet planted perfectly flat. Honestly, this is the ultimate blueprint for biomechanical safety. It really is a stark contrast when you compare setups. Think about the painful reality of a high-risk workstation. You've got a worker frequently reaching way outside their primary strike zone, which causes severe shoulder strain. They're stuck in static sitting with a hunched spine, using rigid, non-adjustable furniture. But then, you switch to a truly ergonomic setup, and it completely changes the game. High-use items are right there within the primary reach envelope. You've got dynamic seating, neutral spinal alignment, and fully adjustable furniture that actively adapts the machine to the human form. Moving on to Section 2, Anatomy of the RSI cycle. What actually happens when those biological limits are totally ignored? When you look at musculoskeletal disorders across different industries, it's wild how different hazard environments dictate completely different injury zones. In offices, prolonged static sitting and substandard setups are literally destroying the neck and shoulders of support staff. Meanwhile, over in manufacturing and assembly lines, awkward static postures and highly repetitive manual tasks are heavily impacting the lower backs and limbs of workers. The job entirely dictates where the body breaks down. But how does this build into a chronic, long-term problem? Well, it happens through a very predictable 5-step RSI cycle. It all kicks off with Step 1, an ergonomic mismatch, where the workstation demands movements outside the body's natural limits. This introduces Step 2, hazardous exposures, like repetitive movements and awkward postures. Step 3 is where the actual biological damage begins. Continuous loading causes microtrauma, literally tiny tears in your muscle and tendon fibers. And because of Step 4, which is insufficient recovery and a lack of proper rest breaks, the tissue simply cannot repair itself. This inevitably locks the body into Step 5, chronic inflammation, persistent pain, loss of function, and full-blown clinical injury. All right, let's pivot to Section 3, Malaysian law and employer duties. How do we legally stop this cycle? To really understand this, we need to look at the whole ergonomic ecosystem. The physiological reality we just talked about, the science, intersects directly with the standard. Those are the prescriptive guidelines from the Department of Occupational Safety and Health, or DOSH. But the actual linchpin holding all of this together is the Occupational Safety and Health Act, OSHA 1994. That is the mandatory legal framework that actually enforces responsibility over the physiological reality. OSHA 1994 carries absolute authority, providing 3 main legal shields. Number 1,
To secure the safety, health, and welfare of persons at work against risks. Number 2, to protect persons at a place of work other than the actual workers themselves. And number 3, which is totally crucial for our topic today, to promote an occupational environment adapted to physiological and psychological needs. Make no mistake, these are heavy, definitive employer responsibilities carrying the full weight of national law. But OSH 1994 also requires balance. It clearly delineates duties between Section 15 and Section 24. On one side of the scale, the employer has a massive duty under Section 15 to provide and maintain safe systems of work, a safe environment, and crucial instruction and training. But look at the other side. The employee under Section 24 has a strict legal duty too. They have to take reasonable care, cooperate with the employer, wear the provided protective equipment, and actually comply with health instructions. Both sides absolutely must function together to keep the ecosystem safe. Now that we have the law down, let's get into Section 4, identifying and assessing risks. These are the practical steps you'll use.
Under Section 18B, there is a strict duty to conduct risk assessments. Let's walk through this continuous loop because you're going to use it a lot. You start at Step 1, identify. You locate the hazards like those awkward postures we talked about. Step 2 is evaluate. You conduct formal risk assessments to determine just how severe and probable these disorders are. Step 3 is control, implementing actual ergonomic interventions to eliminate or reduce that risk. And finally, Step 4, monitor. You review how effective the new workstation design is and tweak it if needed. This is a highly actionable methodology, so definitely memorize it. To do that evaluation step properly, you need the right tools. Two vital ones are ROSA and RULA. If you're in an office or administrative setting trying to prevent static strain, you use ROSA, the Rapid Office Strain Assessment. But if you're on a manufacturing floor dealing with repetitive, forceful work, you have to deploy RULA, the Rapid Upper Limb Assessment. RULA focuses intensely on the neck, trunk, and upper limbs. So remember that heat map we discussed? You always match the diagnostic tool to the specific injury zones of your environment. And binding all of these specific, targeted assessments together is the DOSH era. The Ergonomics Risk Assessment of 2017 is your comprehensive national standard framework. Think of it as the ultimate guideline, integrating all these different tools into one unified system for national legal compliance across all Malaysian workplaces. All right, home stretch. Section 5, engineering the ergonomic solution. How do we build this stuff in the real world? Let's unpack some specific prescriptions from the latest 2024 DOSH guidelines, starting with seating and screens. There is a strict requirement now for dynamic adjustability in seating. They are specifically focusing on lumbar support mechanisms and adjustable armrests to actively take the strain off the shoulders. For display screens, maintaining that line of sight geometry is an absolute necessity. You've got to mitigate screen glare and position those screens perfectly to prevent any cervical flexion, making sure the neck stays in a totally neutral posture. And for jobs that are more physically demanding, the guidelines are just as rigorous. If a worker is standing, the 2024 guidelines note the critical provision of anti-fatigue matting and mandatory footrests to help shift body weight around. Now, for manual handling, which is governed by the 2018 guidelines, the golden engineering rule is keeping heavy loads tight and close to the body center of gravity. And you must entirely avoid twisting your torso during a lift. No exceptions. This right here is where things get incredibly cool. Digital Human Modeling, or DHM. This represents the cutting-edge future of OSH engineering. By simulating workstations with digital avatars before anything is ever built, engineers can ensure anthropometric compatibility automatically. The software can literally calculate those RULA and ROSA scores predictively based entirely on the avatar's movements. This is a game changer. It shifts our entire industry from merely reacting to injured workers to proactively designing spaces where getting injured is biomechanically impossible from day one. I want to leave you with a final thought that perfectly summarizes OSH 1994. Ergonomics is not just a wellness perk. It is a legally mandated objective to fit the environment to the human. I really want you to think about that deeply as you step into your future roles as safety professionals. You aren't just there to make people comfortable. You are enforcing national law. You're protecting human biology, and you are engineering a safer world. Master this material, because honestly, you have to ask yourself, are the workstations you, your friends, and your family are sitting at right now breaking the law without you even knowing it? Think about that, and I'll see you in the next explainer.